Professor's going wild. Algebra going wild. Algebra going wild. Not something I'd watch.
Okay, I hope you enjoyed your vacation from my class. While you were away, there was a worksheet, and there was also some homework for the book on page 464. I will answer questions from any of that to start out today.
Can you do the word problem from the book in number 25?
Oh, you know, there was something about the book word. I'm glad you said that. Yes, I can. Page 464. After looking at the homework closely, I realized that I had assigned something that you couldn't do, well, without reading it. Something we did not go over, which was 27 through...
You omitted that.
Yeah, you told me not to do that.
Oh, good, because the last class before you, I guess I forgot to tell them to admit that, and they all did. They were mad. Good, you guys did get the word to omit that, right? Good. Okay, so what was the one word problem that you wanted to see?
It was all of them.
Which was, name one.
85, 87, 89, 91, 93, 95, and 25. Please.
I second the motion.
Yeah. We will have so much more knowledge after today's lessons to do this one, because the book prematurely put these questions in here without giving you all the proper tools. So let me show you the two methods, these two worksheets today. It will clearly show us something we need. Otherwise, you guys are going to look at me like I'm crazy when I show you how to do it. So just postpone those pieces, okay? All right. How about this? Anything from 1 through 25 or from 43 to 83?
25.
25. And on the worksheet, remember the worksheet that was solving equations, exponential equations? Anything on there you wanted to take a look at? Solving logarithms, or something about properties of logarithms, I forget what it's about. Do you have a worksheet?
I did. I put your name on it.
Okay. What do you have? What was the name of it? Yeah, it's the meaning of logarithm. Anything from that particular worksheet you want to see on the board? Okay, number 11. Those would be good warm-ups right there.
And anything out of that last section? I forgot how to,
35?
no, 34. Yeah, sorry.
Okay, and
We do 61 from home.
61.
Okay, there's 59 too. I don't really understand the x equals e's and then,
Okay, so pick one.
I guess
59?
59, okay.
59 is good.
Can you do 73 from the book too?
Sure. Okay, let's start with the worksheet, knock that out. Guess I'll borrow Ross's. All right, number 11 says the log base 7 over 4 of x equals to y. And it says to rewrite this in exponential form. Well, we need to remember that log base a of x equals y is the same thing as a to the y equals x. As a matter of fact, quickly tell me, if you might, what's the relationship between those two operations? Might be a stretch here for you guys to remember this. One way to put it would be they're opposites, but what's a mathematical way of saying opposite relations? Inverses, okay? So that's something you should be thinking about. They're really inverses. They undo each other. Okay? But basically, if you take a look at this side and just match up the pieces, or remember the nice little circular motion that we talked about, you can have 7/4 raised to the y is equal to x. That should be the exponential version of this law for number 11. And for number 34, oh yeah, we have 5 raised to log base 5 of 17. Well, again, if you realize that these two operations are inverses, maybe you can see right off the bat that the answer to this has to be what? 17. But if you don't see it that way, let's go ahead and rewrite this as an exponential, excuse me, a logarithmic equation. Here's one piece, here's the exponent, here is the base. So if you look at the base, that's down here, so I'll write this as log base 5. And then in here I have an x, which is going to be my x, is equal to the exponent y, which is log base 5 of 17. That would be turning this back into a logarithmic equation. And now you can see where the x and the 17 line up at the same place. So the answer clearly is 17 here. You see, log base 5 of 17 would be log base 5 of what? Well, 17. You see that? That's the way to do it mathematically, but hopefully you can see these are inverse operations. They basically cancel each other out, 17. Okay, so here, log, I'm going to take 5, no, I used 5, how about 12, log base 12 of 370, 62. What's the answer to that? 362. Okay, you see? Yeah, it's easy. Take the base, raise it to a log of the same base, and you've done nothing. Is what's going on. Okay. All right, that handles. Any others on the worksheet? All right. Yeah, I thought the worksheet would be pretty tough. That one in my office. I don't have one here. All right, let's tackle this book. We'll start with number 25. Oh, well, I guess I have to say this. Number 25 has to do with the graphing of logs. We did not talk about the graphing of logs yet. You don't have quite the skills to do it, so I have to group those in with the postponement. If you can do 25, you can do 27 through 34. So we'll have to come back to 25, I'm sorry. After today, certainly on Tuesday of next week, you'll be able to do all kinds of work with the graphs. But we need to talk about it first, about what it represents. So did I say only 27? Yes. I should have included 25, because again, it's all in the graph, so I apologize. We will come back to this. You will know how to do it, I promise. Okay, so next on this list is 59. Okay, 59 is something you do need to know how to do. All right, so I guess some of the things you need to realize about the ln, and we talked about the ln, there's another way to write the ln. How is that? Log base e. It is the log that uses e. I think I have it written right up here actually. E is approximately 2.7128, something like that. It goes on infinitely, just like the number pi does. It's a non-terminating, non-repeating decimal, an irrational number. Its meaning, we could take an entire week to talk about its meaning, but we talked about the fact that it exists. It was named after the person who is credited as discovering it, Euler, from he's a Frenchman, I think. And, anyways, the point is, this is just nothing more than a nice number which is bigger than 0, not equal to 1, so it's a perfect candidate for a base. And since we use it quite a bit, it's actually got its own name. It's the only log that has its own name. Log without anything written on it like this has a special meaning too. That means log base 10. So when it doesn't have a base written there, it's an implied 10. Everything else will have a base, and if it has a base of e, furthermore, they just call it the ln, or natural log. So if I do that for this problem right here, I can say the log base e of x is equal to 1, and then do the nice motion that we know how to do. We have e to the 1 equals x. In other words, x is equal to e. So that should be the answer for that 59, was it?